shaped like a half cylinder. So generally we think of a cylinder from geometry as being a vertical cylinder. A Quonset hut is a place where you would live. So it's laying on its side and then it's cut in half. So that the ground is like the floor of the house. And I have a picture so that you can kind of get an idea because it makes a little more sense when you actually physically see what it looks like. So that's an example. So this would be like on HGTV when they do their like weird houses. Like this is probably one of those houses, something like that. Obviously we don't see them, but I'm sure there are other areas where they would have them, but not a standard Western Pennsylvania type of house. So the question is saying that you have 600 square feet of material to build this hut. So that means the arched part and then the front and the back are the parts where our material would have to go. I mean, some kind of siding or something is going to make the hut. Our goal is to use the surface area to find out or solve the surface area equation to solve for L. And then using that, we're going to see if we can find the max volume. Volume is what would be the space inside. Generally, when you think of a house, you don't think about the volume of a house. It's always given in square footage. So a house is like 1,600 square feet, or a house is 2,000 square feet. But the volume takes into account then the height of the ceilings. And that's probably pretty important for this style of house because you figure like the sides are sloped, and the higher the ceiling, at least the more space that you would feel like you would have inside. So the equation that we're starting with, bump back here, is the surface area equation, and they ask you to plug in 600 for S because that's the amount of material that we have to work with to build this hut. And then it says to solve for L. L is the length of the building, so how long is it? And that's the part that would be like going back, the length or the depth of the building. How would you solve for L? I forgot my plus sign here. So even if I'm solving for like y, if I had an equation that was like 7x plus 3y equals 8, kind of the same thing. Like what would you need to do to get L by itself?
Subtract pi r squared.
Yeah, we need to subtract pi r squared. So whatever quantity is being added or subtracted with the variable we need to get by itself, you've got to move that part first. So we have the 600. Now we're subtracting pi r squared. And we have pi r L. And then Emma, to get L by itself, you would
Divide the whole thing on the left side by pi r.
Right, so we're going to divide by pi r. And everything gets divided by pi r. So if you think about it as each piece individually, the 600 is divided by pi r, and the pi r squared is also divided by pi r. So if I'm solving for y equals mx plus b, I would divide the number with x by the value. I divide the other, like I need to divide each piece. So depending how many pieces are there, think of it, each piece has to be divided so that you can try and reduce them. 600 over pi r squared cannot change. Just keep the pi in the problem. Don't make it a crazy decimal. But what's the second term become? So we have pi r squared divided by pi r. What's left, Emily?
Minus r.
Yeah, just a minus r. Because our pi's cancel, and then r squared divided by r is just r. And that's now equal to L. So if I were to find the length of the building, the depth of the building, how long it is, if I knew what the radius would be, then I would be able to figure out that length. So if the radius was 5, I could calculate the length. If I wanted a radius of 10, I could calculate the length. Questions with part A. So that would be part A's question, where it says solve for L. Part B then says to use the volume formula. So the volume of a cylinder usually is pi r squared h, and I even wrote an h up here. It's supposed to be an L. Usually, there we go. Usually we use an h because a cylinder is a vertical cylinder. They're using an L because that cylinder is laying horizontally, so that's why it's an L there. The 1/2 is there because we have a half of a cylinder instead of the whole thing. So if you remember any of the geometry formulas from last year, maybe this one looks a little similar, pi r squared h. That was like chapter 9 maybe. You guys want to forget about all those formulas from last year? All right, so the directions say to solve the polynomial function, I shouldn't say solve, but to write an equation for the volume of a polynomial function with r by substituting the expression for L from part A into the volume formula. And that's a little wordy, and it kind of makes like the words make it sound a little confusing. But all they're asking you to do is to take the equation you just found, use substitution, and replace it in the volume formula, so that my equation has one variable in it instead of two variables. So if I just solve this for L, we can come over to the volume formula, and instead of L, we can replace it with the equation that we just found, which would be 600 pi r minus r. Any questions with that part? So then how do you simplify it by getting rid of the parentheses? How would you do that? So what would you have to do to eliminate the parentheses from the problem? What do you do with the thing outside? Numbers are outside the parentheses. What do you usually do with them, Sarah?
Multiply.
You multiply them. So you multiply them into the parentheses. So we're going to take 1/2 pi r squared, and we're going to multiply it into the parentheses. Now I'm going to write it out first so that you can like really see how I'm multiplying this. But we have 1/2 pi r squared. I'm multiplying that, I'm going to put a little times here, with 600 divided by pi r. I'm just writing it like that so that you can see how it will reduce. And then we're taking that same piece, there's a minus sign, so I'm going to pull a minus sign down, 1/2 pi r squared, and then that second part is just a times r. So when you're using the distributive property, you're taking the outside number, multiplying it by the inside number, taking the outside number, multiplying it by the inside number. We just happen to have a 1/2 a pi and a r squared on the outside. So if we try and do some simplifying, we have a 1/2 and a 600. What would they break down to be, Emma? 300. And then pi r squared is in the numerator. It's on the top. So I'm going to write it next to the 300. Pi r is underneath on the bottom. And the next term, we have a minus 1/2 pi. How many r's do we have in that second term? 3, because an r squared and an r make an r cubed. Does anybody know what the volume formula would be once we do some reducing? Sarah?
300 r minus 1/2 pi r.
Good. So 300r and then 1/2 pi r cubed. Does the pi's cancel? R squared divided by r goes down to just r. So yes, the algebra in this is tricky. Is it anything that we've never done before? No. We've done a lot of algebraic skills already, and all those skills we've done, you just need to know how to use those skills and apply them to problems. So the last part of the question says to find the maximum volume. So using this equation, what would the maximum volume of our hut be based off of our original area of 600 square feet? So how do we find maximum volume? Sarah, did you have a question?
I think I have the maximum.
How do you find it?
Sorry, my like works really
That's all right.
so I thought I could do that.
So what do we need to do to find the maximum volume? Elena? Yeah, we need to use a calculator to graph it. There's no physical algebraic way that we know right now to solve for a maximum value. We can find the r or the x, we can find x-intercepts, we can set it equal to 0, But we can't find a max without using the calculator until you get to calculus, because it really is a calc concept. So with your calculator, if you can plug this in your calculator, using what we did yesterday with the calculator, how we changed the window. Plug this in, see if you can get a window that shows you the max of the curve. Remember, your goal is to see that top part of the curve. So you're going to have to change the window so that you can see the top part of the curve. So we're using the 300r minus 1/2 pi r cubed. And trying to get that top part. And remember, that's called like the turning point, the critical point, the local max.
Do you want me to give you?
Nope, just wait. I'll get you then. So once you plug in that equation and you graph it, you should see nothing in your calculator. Because it's way too big. So yesterday, I think we used 500 yesterday for the Y max. So that might be a good starting point, like use something that we've already used before. And if you hit 500 and hit graph, you see something now instead of nothing. But 500 isn't big enough because we still don't see the top of that curve. So try something else. Go to the Y max and try a different number so that we can get the whole peak of the curve. You can closer. Oh, wait, you did go less. Ben, did you find it in your screen? No. I think what did you use? 2,000? Yeah, I think 2,000 works pretty nicely. You could use 5,000. Wrong button. 5,000 works, but it's kind of a large value, almost too large. So your goal is to try and use the number, the smallest number that you can use to make sure that it's still graphable in your screen. So that's what it looks like if you just change the Y max. So we can see the curve. I'm going to just make one other change so that I could kind of see a little more of the curve, and that would be changing the X max. I'm just going to make it 15, just so that you can see a little more of the curve. So now I can see like that part that goes up and goes back down. You didn't have to do that. So if you only change the Y max and that's where you stop, that's fine. But now that we have that in the calculator, you can use that max function, and Sarah, I think you have it.
1,600.
Try it again. So use the calculators, like do the second calculate, and then number 4. Emily, do you have something different?
For the max, I have 8 and 1,595.
Yeah, I think it's really close to 8. Is it 7.98?
Yeah.
And then you said 1,000.
595.8.
So it'd be 595. We'll keep it like that point. So really it would be 1596 and 8, I guess, if we were rounding up to whole numbers. So the x value really in our problem represents what? So what does the x represent? The radius. So the radius is about 8 feet. It's approximately 8 feet. And we could say the volume is about 1596 feet cubed because it's volume. So remember, this is R. We were solving for volume, so the Y means the volume. What's the other dimension that we should find? Because it asks for the dimensions. The length, yeah. So remember, going back to our picture, so if we're looking at the picture now, not what I wanted, right here. So the radius is 8 feet. Well, the diameter would be what then if the radius is 8 feet? 16, right. So my whole entire diameter from side to side is 16 feet. So this is a 16 feet wide hut. And then the length is the part that goes back. So almost like the depth of it. And we can find that just by using the equation that we already have for length. Right here, it's 600 divided by pi times, we'll say 8, and then minus 8. So you're taking 600 divided by, you might want to put pi and 8 in your parentheses or multiply those first and then divide. And then you're subtracting 8 from that. And it's also about, I think it's about 16 feet. So the length is about 16 feet. So the radius of our hut is about 8 feet, the length is about 16 feet. And that gives us then the most volume inside the hut. Any questions? Emma?
Yeah, why were you trying to find
The what?
the length?
It asks for the dimensions. So the last part of part C says what would the hut's dimensions be. See that last little part. So my dimensions in this case would be the radius and the length, along with then the max volume. Other questions? If you look at, I just want to do 2 problems from the riddle sheet. So if you look at the riddle sheet, it's just the front page. So I'm going to go through a few problems with you just to review, and then you'll have the rest of the period. So at the top of the riddle sheet, it asks what type of tree, what does it say? What kind of tree does a math teacher climb? And if we do a couple of these, I think they'll figure out what the answer is. So if you look at number 1, just working through this quickly here, when there's an exponent outside, what do you do with that exponent outside? I heard it. Distribute, multiply, not add, which a lot of people on the first quiz added those exponents instead of multiplying them. But when there's a power outside, that's when you distribute or multiply it through as an exponent. So we would have 3 to the 4th, x to the negative 8, y to the 12, and then 36xy to the 6th. So then simplifying, what is 3 to the 4th? Alice? 81. Alice, what do you do with x to the negative 8? Yeah, take it down to the bottom. So that moves down to the bottom. So Alice, what would the power of the y be? 6. And then if we take x to the 8th down to the bottom, what would the power of the x be? 9. Good. So we have y to the 6th, because 12 minus 6 is 6. It stays on the top because the largest power is on the top. X to the negative 8 moves down to the bottom. Well, there's already an x down there, so now I have x to the 9th. Does 81 and 36 reduce? Yes. Say it again. 9 over 4, yep. So 9 y to the 6th, and then 4 x to the 9th. So what letter is that? G. So our word starts with a G. All right, if you go to the last problem and look at number 9, or I'm sorry, number 8, there isn't a number 9. Number 8 says find all the real zeros of the function x cubed minus 17x squared plus 30x. What are you finding if you're finding the zeros? Alex? The x-intercepts. So you're going to need to remember, if it says to find a solution, you're finding x. If it says to find zeros, you're finding x. How do you find them? Like, what process do we know to find x-intercepts? Ben?
Plug it into the calculator.
Well, sure, you could plug it in the calculator, but I'm pretty sure the calculator's doing all the work and then you're not doing anything, which isn't really any fun. What other method could you use, Ben, besides the calculator?
Factor.
Yeah. Which one do you think I'd prefer?
Plug it in the calculator.
Plug in, oh, of course, yeah, definitely. We should just have calculator class, calculator math, right? So this would be a factoring problem if you're finding x-intercepts.
Wait, that's what calculus stands for, right? Calculator math?
Calculator math?
Yeah.
Maybe you should tell Mrs. Everhart that. Considering half the AP Calc test is without a calculator. But maybe she'll go for it. She seemed pretty nice when you were over there, right?
Yeah, she was
Nice
pretty
lady?
nice.
Yeah. What would you take out, Mitchell, since you want to do calculator math?
X.
X. So if we take out an x, we get x squared minus 17x plus 30. And then, Mitchell, what else would you do to factor it?
I would do the multiplying,
Mm-hmm.
and then I'd get negative 15 and negative 2.
Okay.
And then I'd do x squared minus 2x. And then I'd have another area slightly to the right. That would say 30 minus 15x. Yeah, like that. Yeah.
Okay. And then pull out in.
GCF, which would be x.
Good.
And then negative 15.
And the other parenthesis would be
Minus 2.
so Mitchell pulled an x out here, you get an x minus 2. He pulled out a negative 15, you also get an x minus 2. Don't forget about the GCF. That was also taken out in the first step. So how many answers do you have? 3. The first x is 0. The second x is 15. The last x is 2. So if you look at the letter y, it should say 0, 2, and then 15. That's my mistake, I forgot the one with it. So it starts with a G and it ends with a Y. It must be geometry. So you do not have to complete the rest of that worksheet, but you do have about 17 minutes to work on the chapter review. If you look at the back of the chapter review, so it says chapter 5 review at the top. If you flip it over on the back, I was able to squeeze the answers on there, but in my rush to get them copied so that I could hand them out yesterday to those that were not going to be here today, letter B should be, or I'm sorry, number 2 should be B to the 12th and not B to the 6th. That worksheet will be collected from you tomorrow, so when you come in, come with the worksheet in your hand so that I can take it from you, and I'll give you the test in exchange for it. The test should take about 30 minutes, but as you know, some people take a little longer, but it's meant to be about a 30-minute test. No extra time, so when you come in, you get it, you work on it, and then when the bell rings, that's it. Question?
I have a question on that.
Yeah, I'll come over. So please grab a partner to work. I'm going to come around and check the homework. So if you could keep the homework